I'm Jara from the future. I hope that you understand this explanation about topic 5 of the description of movement in one dimension. See you in the past.
The first concept is distance, that is the length of the real path followed by an object. Then, we can say that it is scalar quantity because it only has magnitude and a unit. Then we have displacement, that is the separation in a straight line between 2 points. It's a vector quantity and has magnitude, direction, and a unit. The distance is represented with the letter D or the letter S, and the displacement is represented with the capital letter D. We have an example of how to identify displacement and distance. The displacement is
First, we need to have the total distance by adding the 700 meters that the car traveled and the 500 meters. That gives us 1,200 meters. Then we need to know the displacement, and we need to rest them because they go in opposite directions. 700 minus 500 meters equals to 200. After that, we need to write the formula of the average speed, that is distance over time. Then we're going to substitute the values 1,200 meters over 120 seconds. This gives us 10 meters over second, and that is our average speed. Then we're gonna write the formula of the average velocity, that is displacement over time, and we're gonna substitute the displacement, that is 200 meters over 120 seconds. This gives us 1.66 meters over second, and that's our average velocity.
instantaneous speed. It is a scalar quantity and is the rate of change of distance over time. Then we have instantaneous velocity, that is a vector quantity. Is the rate of change of the displacement over time.
First, we're going to write the formula acceleration equals final velocity minus initial velocity over time. First, our initial velocity equals to 0 because it starts from rest. Then our final velocity, that is 60 meters over second, and then it's 15 seconds. Then we're going to substitute all our data, and we're going to have a result of 4 meters over square second. To solve uniform acceleration exercise, we need these formulas, which includes position, final velocity, initial velocity, acceleration, and time. We're going to start with the second question, and we're going to find final velocity. And we're going to need the second formula, initial velocity plus acceleration times time. The initial velocity is 0 because it starts from rest, so we're going to multiply acceleration times time, and this gives us 80 meters over second as a final velocity. Then we're going to find position, and we're going to use the first formula, that is initial velocity plus final velocity over 2 times time. Then we're going to substitute all our values, and the position is 400 meters.
We're going to talk about the 3 kinds of graphs to analyze the motion of an object. We can find the concepts of position, velocity, and acceleration. Here we have some examples. When the velocity is constant, the velocity will not increase or decrease, and this means that the position will always remain constant and it would go in a positive slope. Then we have the acceleration, that it will always be 0 because the velocity is not changing. In here, if we have a constant acceleration, this means that the velocity is constant and the position will increase in a positive.
Then we have this concept of